Good evening for all of you. Am I audible for everybody? Please, can you confirm it? Can you please confirm, dear students, all of you? Yes. Right, students. Now we will move forward. In the last session, we started. What we started in the last session? Did you remember? NumPy? We started NumPy. So in NumPy, why NumPy is most useful? What is the purpose of NumPy? Come on, quickly. What is the use of NumPy? To solve complex mathematical operations. To solve the complex mathematical operations. And we have seen in the last session also, differences between traditional list and then Python. Python traditional list and then NumPy. We already discussed in the class. Okay, now it is a time to see, to move forward. And later we entered into the NumPy. In NumPy, we entered into the most important object we entered. In which object you will organize the data in NumPy? In which object you will organize the data? Object of ndarray. Yeah, object of ndarray. Yeah, an object of ndarray organizes the data in the form of, right? Yeah. So already we done ndarray object. That is the most important part we need to remember. One question I want to ask you. NumPy was developed in which languages, guys? NumPy was developed in which languages? C and Python. Right? Why C was used internally? Why C was used internally? For fastest execution purpose. Why Python was used internally? Why Python was used? For comfortability of the programming. For comfortability of the programming. So they used that type of operations. Okay, students, let us move to the further discussion in the class. Further discussion in the class. Let's move to the without late. And yesterday's class, we started number of approaches to create an object of, number of approaches to create an object of, yeah, number of approaches to create an object of ndarray. First one we discussed in the last session. Did you remember or forget? How many approaches are there? How many approaches are there? 7 approaches are there. We started with what? Array. Still it is going on. ndarray. Look at that. Array. So we created what object? List object we created. What is the dimension? 2 attributes I told you yesterday. What is that? D type. What is that? ndim. So see, we are coming across ndim. So today we will cover this point also. Attributes. Yes, ma. Attributes of what? ndarray. Attributes of what? ndarray object. What are the attributes we discussed? We have seen it last session. We have seen about attributes. What are the attributes we have seen? First attribute is called what? D type. Next attribute we have seen what? ndim. Dimensional, n-dimensional. Okay. At the same time, my dear students, please visit to the Python here. Let's watch this carefully and observe this. Carefully. 3.9. Let us move to the further. Yeah. So last session we completed like this. Still, I want to move forward. Example. This is called one-dimensional array. Please be careful, ma. All of you must be little active. Compared to Python, you need to be active. Yeah. Let's go to this place. I am going for 2-dimensional because this array function is most useful, ma. The total story is there with this only. Okay. Other things are dead easy. You can understand. This is very, very useful to you. Okay. Array function. Please let me go to it once again. L is equal to, carefully understand. I'm taking something like this. 10, 20, 30. 10, 20, 30. 10, 20, 30, comma, 30, 40, 50, 30, 40, 50, or 40, 50, anything you take it, 30, 40, 50. Okay. Next I will take it. That something like 15, comma 25, comma 13. This is called my data. Say that. What is your opinion about it? One list. Inside of it, another list. This is called one list, another list, another list. This is called. So beautiful. So see that print of L, print of L, print of L. Inner list concept. So I want to convert into ndarray. A is equal to, dear students, I need to import what? Yes, ma, I am interested in doing this. How do you do it? NumPy. I should say import NumPy as NP, some type of what? Some type of import alias name, NP. You can take your own name also, no problem. Import NP. Yeah, print A is equal to NP dot array of L. See that. A, you print A. See how it is printing? It is printing array. It is the array. It is a list. Inside of this first row, second row, third row. First row, second row, third row. Rows and columns organization is called which dimension? Rows and columns. How many? Two-dimensional it is called. Two-dimensional it is called. Print of, see, again I will write it, A, comma, type of A. See that it is a matrix is printed, ndarray, NumPy, ndarray. Print what? A dot D type, data type. It is going to contain int 32. All of them are integer values. Next I will print A dot ndim. So it is going to give you ndim. I say ndim, which is going to give you the dimension. N-dimensional. Which dimensional? Rows and columns, which is going to give you 2, 2. That is called 2 will come. 2 will come. That is called 2 dimensions. Rows, columns. Are you getting my point? Rows, columns, 2 dimension. Now today we are using one more kind of thing, my dear students. A dot shape. What is the shape? How many rows are there? First row, second row, third row. First column, second column, third column. What is the shape? 3, 3. See, my dear students, 3, 3. Such a type of facilities were not there in the list. Come on, quickly, like a data types only we need to learn it. So what is the other attribute, my dear students? What is the another attribute here? Shape. Yeah. Coming to the point of it, I will take, this is called one type of which mechanism this is? I will take it. Look at that. I will just to carry on this kind of things in this place. So it is going to give you the example for 2D array. This is called 2-dimensional array. I am just mentioning here examples for which array, dear students? 2-dimensional. Yeah, 2-dimensional arrays. 2-dimensional arrays. Examples I am talking about it. Please understand me carefully. So here I am writing. Under that, I am saying print of L. I am getting this. Under NumPy, you try to use, okay, A dot printed here, A dot printed once again, A dot D type, and A dot ndim, printing 2 dimension. That is nothing but rows and what? Columns. Rows is 1 dimension and columns is another dimension. Shape is called what? 3 rows are there, 3 columns are there, 2 dimensions. That is called 2. Is it clear? I will go to one more example. Let's take once again here. I will take, yes, Let us take L itself once again. You see, I will take like this. L, print of L, A is equal to NP dot array of L, print of A comma type of L, type of A, which is going to give you this part. Yeah, don't get confused. A dot ndim. What is that ndim? Dimension is what again here? Dimension is again 2. What is the shape of it? Print of what? A dot D type. That is very simple for you. Print of A dot shape. What is the shape, please? It is called, how many rows are there? 2 rows are there. 3 columns are there. 3 rows, 2 rows are there. 2 columns are there. Right, students? It is called one more kind of example. Let us go to the next discussion in the class. Next discussion I will go for it. Simple. What is this one called? What is this one is called? One dimension. Example for one dimensional array. I can say one simple word. It is mostly used for arrays organization. That's it. Right? Arrays related operations, we use it. Next, most important thing I want to cover it. Yeah. 3 dimension I want to cover it. 3 dimensions I want to cover it. Shall I cover it? Shall I cover that? Yes. Dear students, be careful. Sir, how do you cover that? So, let us watch this example carefully. L is equal to, very careful, very careful. See, I say 10, 20, 30, comma, 40, 50, 60, 70, 40, 50, 60, comma, next 70, 80, 90, This is called, see, first matrix, first row, second row, third row of one matrix. See, I say here, close it. This is called one matrix. I say, close it again. This is called one matrix. One matrix contains 3 rows, 3 columns. One matrix. One more matrix, I let it, comma. This is called a comma. One more matrix, I will write it. One more inner list, I will take it. See, 1, 2, 3. 1, 2, 3. Again, inner list. Please observe it. Comma. 4, 5, 6. Comma. 7, 8, 9. 7, 8, 9. Close it. And total close it. See, I will just put the bracket. This one. Observe it. This part. And the next is called what? This one you see. You see this one. And see this. This is called one matrix. This is called 2 matrices. 2 matrices are there. What are the dimensions? 3, 3. 2 matrices are there. What is this? Each matrix contains what? 3 rows and 3 columns. This is called 3-dimensional matrix. Is it understandable, dear students? Yeah, simple ma. Because we already had a discussion. Print of L, type of L. Beautiful. Because the beauty behind is only inner list. Such a type of inner list mechanism I am converting into ndarray. A is equal to np dot array of L. See that beautiful print of just A you print it. See that A. See ma, this is called one matrix. Another matrix. How many matrices are there? First matrix and second matrix. How many matrices are there? Two matrices are there. Each matrix contains what? First row, second row, third row. First column, second column, third column. Three rows are there, three columns are there, each one. Three rows are there, three columns are there, each one. And you don't get a doubt, sir, this is one order, this is another order. Don't get that type of thing. You need to get what? Equal order must be there, because mathematically you are aware of it. Now print out. Yes, beautiful. Ndim. What is an answer? What is an answer? Can anybody can say? What is an answer? Ndim. Three will come. Three will come. What is the shape? Yes, shape. Excellent. 2, 3, so beautiful. 2, 3, 3. 2, 3, 3. If it is our C programming, C++ programming, Java programming, such a type of construction was very, very difficult. But in Python, it is a dead easy, because we are using some third-party module called what? Third-party module called what? NumPy. What is the index of this? What is the index of this entire one? What is the 0? Super. What a beautiful knowledge you have. What is this index, please? 1. Please print it. Print off. Here only you write it, ma. Here only, because already we had a very beautiful knowledge. See that this index is printing. Super. You are already well deserved for it. A of 1. See that I am getting whichever matrix I want, I will get it. Whichever matrix I want, I will get it. Super. Are you able to understand me? Yes. 2 matrices, 3 rows and 3 columns. Anvita, exactly, ma. Is called shape. Yes, Manvita, exactly. So I hope you are understanding. Right. Simple, ma. Joshita. Yes, ma. Joshita. Simple, ma. This is one matrix. How do you design that matrix? You observe it. This is called 1. This is called 1. This is first of all list. This is called list. Okay, na? This is called what? List. One list. Inside the list, first I will prepare one matrix. How we prepared this is one inner list. This entire thing will be under what? One list. This is called one list. This is called one list. It is called one matrix. These are called inner list. Okay, ma, Joshita, please listen. This is called another matrix I am going for. I am planning to go for another matrix. This is called one row, another row. So first matrix, second matrix with 3 rows and 3 columns. First matrix, second matrix. 2 matrices are there. Each matrix contains 3 rows and 3 columns. That is called 3-dimensional arrays. 3-dimensional arrays. Are you containing? Right. In 2D, one matrix only will be there. See, ma, in 2D, one matrix only will be there. In 3D, how many matrices will be there? How many matrices will be there? 2 matrices will be there. Rows and columns depends on your choice. You can take it. You can take it. Are you able to get my points? Are you able to get my points? Yes. So we are in a position to go for 3-dimensional matrix also. 3-dimensional matrix also. So coming to the stage of example here, we build what? Examples. What is this? 3-dimensional. Yeah, I'm writing here 3-dimensional matrix. 3-dimensional matrix I build. So I printed this first matrix, second matrix, and then already done. So shape is called this one, and ndim is called something like this. A of 0, first index I got it. Yes, beautiful. I got this output. Next is called A of 1. I got this output. I got it. Yes, beautiful. We got this type of things. I hope that this is more clear. Am I clear? Am I clear about this? Yes. So I hope that it is more clear. This is called which function, ma? Which function I used it? Array function. Array function. So is array function is clear? Is the array function is clear? Yeah. This is called array function. Shall I go to the next function? Shall I go to the next function? A range function I am going for. A range function I am going for. Yes. Under this, please let me go for this A range function I am going for. A range. This is the function I am going for. What simple thing. See, already we had a discussion about range function. Did you remember the range function, my dear students? Range. What is the range function, please? Range function for x in, see, just have some exercise about 11. What I am printing there? Print of what? Print of what? X. Print of x. It will print 0 to 10. 0 to 10. Yes. For x, comma, what is this? 10, comma 16. 10, comma 16. I am printing print of x. Print of x. It is going to print 10 to 15. 10 to 15 it is printing. For x in range of 10 to 16. 10 to 15 it is printing. Next time printing 10, comma 20. 10, comma 20, comma 2. 10, comma 20, 2. Print of x. What are the values are printed? Start, stop, end. Beautiful. So see the answer what is coming. 10, 2, 14, 16, 18. Today also, a range function also used for generating range of values. Range of values. It is used to generate the range of values. A range function is also used for generating range of values. That means it will generate only one dimension only. It will generate only one dimension. Let me go for it. Once a small example I will give you. So what is the syntax of a range function? First of all, you understand the functionality. This function is used for generating one-dimensional array of values. There is no capability to design two-dimensional array directly. There is no capability for us to define directly three-dimensional. We can't design it. We can't design it. Okay, how to design, sir? Just I will write it. Let me write the syntax first. Let me write the syntax. Easily you can understand. Variable name is equal to variable name. Directly it is nothing but what you know. Directly it is nothing but I can write ndarray object. I can write it directly. We had an knowledge on it. np dot numpy dot a range. What is that now? Begin, comma, end, comma, step. I can write it. Begin, comma, end, comma, step. It is always equal to range function only, but it is a part of numpy. Range, comma, end, comma, step, I can say. So what is that now I'm saying? This function is used for generating range of values in the form of one dimensional, in the form of 1D, but we can't directly create 2D. We can't directly create 2D arrays. But how do you build? I'm going to explain you. I will explain. We can't build 2D. We can't build directly 2D arrays. We can print only what? 1D array. But we can't directly create 2D arrays. Sir, what is the syntax? We did that. Now let me go to the examples. Let me go for it. How easy it is. Let us come. Start. This part you come. Now I'm going to use it. Something like this. Look at A is equal to np dot. Once again I will use it. Import, of course, So separate example as NP. You can take instead of NP, you take your name. A is equal to NP dot a range of something like 10. I will write, for example, 9. I am writing 9. See what is happening. I did not write what begin. Only begin I wrote. End I did not write. Step I did not write. It is nothing but always like what? As I told you, range of 11, like that. It is also going to be created as what? Range of 9. So just to say A. What is printed, you see? Array 0, 1, 2, 3, 4, 5, 6 up to 8. 9 means what? 0 to, already 0 to 8. Print of a dot ndim. What is printed? One dimensional array only. Print a dot d type. It is going to print what? It is going to be int 32. A dot shape. Yes, a dot shape. Don't get wonder by seeing that. Now, what is the shape? Can anybody can say? What is the shape? You will be getting. Okay. You will be getting. Tausif. That is what we should not expect like that. 1 comma. You see, 1 comma 9 comma 1 comma 9 comma. We should not expect. What is that meaning? See, it is going to give you 9. It is giving shape is nothing but number of elements. It is giving in this case. Shape is nothing but number of elements. Always, dear students, it is called 9 elements are coming. Row, you can take it as how many number of one row. Actually, we decided as a 1. But shape will give you in this case the number of elements only. You don't, if it is one dimensional, there is no question of deciding the shape, first of all. First, you please understand that mathematically we may decide it. It is called 1 row and 9 columns. 1 comma 9 in our normal mathematics. But in NumPy, they designed as for 1D, like this type of examples, there is no question of deciding the dimensions. Suresh, please understand. Now I want to design some type of shape. Tell me how many elements are there, ma? How many elements are there? 9 elements are there. Which type of matrix I can form it? Understand with your intelligence. Which type of matrix I can form it? 3 comma 3. Wrong. Very good, ma. Anuj, good. 3 comma 3. 3 comma 3 I can form it. Sir, how do you? Dear students, am I audible for you? Am I audible? Yeah. So I lost my host. Yeah. I came back. Yes. Is it visible? Is my screen is visible? Okay. Let us start now. Let us start the discussion. A dot shape will give you what? The 9. It is not 1 comma 9 or 9 comma 1. It is 9. So I want to reshape. 9 elements are there. Number of elements are 9. What is the possible matrix I can prepare? 3 into 3 matrix I can prepare. For that, we will use the function called reshape. What is the function name? Reshape. So I'm going to say ndarray object dot reshape. Now I'm going to reshape. I'm going to say reshape. That I will put it into some variable called B. I'm designing these elements in reshaping and keeping this. And what is the dimension you want? 3 comma 3. 3 comma 3. See, B is created. Print B, you print it. See that B. 0, 1, 2, 3, 4, 5, 6, 7, 8. It is reshaped. What is the type of B? What is the type of B? See that now. B comma, type of B. Type of B, you see, it is going to be ndarray. Numpy dot ndarray 0, 1, 2, 3, 4, 5, 6, 7, 8. Numpy dot ndarray, it is created. Is it understandable? But A remains the same only. A remains same only. That is nothing but 0 to 8. Is it understandable or not? You cannot go for using 3 comma something like 2. You cannot use like this. See, cannot reshape the array size of 9 into 3 comma 2. 9 elements are there. You cannot reshape like this. Are you following, my dear students? Today, what are you learning? Reshape function. What is my example here? This function used for generating range of values in the form of 1D array, but we cannot directly create a 2D array, but we can, come on, what is the function name? We can reshape it. By using which function? Reshape function of, here I will write rows and calls of which function? ndarray. Reshape function of rows comma calls. So I used here. Let us try to take this example. I will take one more example also. Let us take one more example also. Am I audible or not, ma? All of you? Am I audible or not? Yes, audible. Hassan Ali, please relog in, ma. Hassan Ali, please relog in by yourself. Yeah. So clear it. So try to understand. This is called one type of begin kind of value. I just designed a dot range. Now I just applied reshape also. You see on this part of it, what is my B? You see, you cannot go for taking this. This is going to be called as error. This part is called error. You cannot reshape that elements. Actually, it is dead easy. NumPy, once you understand the subject, now it is easy. Nothing is difficult about it. Okay, come on, coming back to the point here. Next, I want to go for it. Let us go for this case. And B, you print it once you print B. Once you print B, B is printed now. Print B, it is done. Same, there also you try to print. What is that? ndim, B dot ndim. What is the dimension of it? It is called 2. What is the shape of it? It is called 3 comma 3. Yes, sir. On this B, I can apply this part of it. Dimension I applied and then did like this. So here B dot, I applied this part of it. Here I am taking, I will write this area. Dimension I got it. So I got the value called like this, 3 comma 3. A, I got the values like this. Original as it is that A is there. You cannot reshape according to 3 comma 2 because I took like this. Let us take one more example. Last and final I am taking. Yes, sir. A is equal to np dot A range. Of. I'm taking. So, yes, ma. Lavanya, you are asking, can we reshape 6 comma 3, sir? Is it possible to write? Yes, ma. That only I'm going to. That only, ma. Just 1 minute. I'll take your doubt. See, ma, all of you should understand me. So, can we reshape 6 comma 3 of the previous one? Can you reshape it? No. 6 comma 2, no. 6 comma 3, no. I'm going to show you. Let me go to one more thing. Please look at that. Now I'm taking 12 elements exactly. You take it. 12 elements you take it. How do you take 12 elements? 10 comma 12 elements you take it. 23 you take it. 23 or 22 you take it. 22 you take it. 10 to 22. Yes, sir. Print of what? A. Print of A. Type of A you printed. Type of A. How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements. 12 elements are there totally here. 22 minus 10 is 12. 12 elements. Now you redesign. A is B is equal to reshape, please. Reshape. How many possibilities are there? Yes, ma Lavanya. A dot reshape of 4 comma 3. 4 comma 3. Yes, sir. C is equal to print of what? B you printed, just B you printed. B you printed. 4 rows and what? 3. 4 rows, 3 columns. Sir, C is equal to A dot reshape. A dot reshape. What is that? 3 comma 4, sir. 3 comma 4. 3 comma 4. Print of what? C. You can say just C. C is 3. This is reshaped like that. Whatever the way you want. Yes, I can say next D is equal to 6 comma 2. 6 comma 2. D you print it 6 comma 2. 2 comma 6. 2 comma 6. DE 2 comma 6. I'm saying 2 comma 6. I got print of what? E. Print of E. I got it. Right, ma? Simple. Once we understand, it is going to be very, very easy. Very, very easy. So, coming to this area, how you design it, it all depends on you. Okay, ma? Right. Go to the place of it. We will go for one more example here. Depends on how we redesign, depends on that we can reshape it. The main intention of this is how we are using the reshape function. That is what we are going to talk about it. We cannot reshape according to our own convenience. We have to reshape according to the possibility of the matrix forming. Yes, ma, Joshita, you can happily reshape it, ma. Yeah, see, ma, Joshita, E. F is equal to 12 comma 1. 12 comma 1. Happy, you can print F. See, 12 comma 1. 12 comma 1. Yes, sir. F is equal to 1 comma 12. 1 comma 12. Yes, you can print F 1 comma 12. Happy, you can print it. Yes, ma. You can print any one of the way. No issues at all. Joshita, did you understand, ma? Joshita. Yeah. Fine. Good. So this is called which function? Which function we are using? Which function we are using? A range function, which is also going to be applicable immediately. Which function? Reshape function I am using. Reshape function I am using. Yes. Last and final, A is equal to np dot A range. I am using A range function. A range function. Now I am using. What is my function name? 110 comma 10 comma. I will say. What is that now? 50 comma 5. Print of what? A. Print of A. Type of A. What are the values are coming? My dear students? 10, 15, 20, 25. 10, 15, 20, 25. 30, 35, 45, etc. How many elements are there? 4 plus 4, 8 elements are there. How do you reshape it? Come on, ma. Reshape of what? 4 comma 2. 4 comma 2. What? Okay, sorry, ma. A dot, sorry. A dot reshape, print B. What is that? 4 comma 2. 2 comma 4 also 2 comma. C is equal to A dot reshape 2 comma 4. 2 comma 4. I will say C. See that printed like this. You cannot apply 8 possibilities only you can apply. You cannot apply 1 comma 8, 8 comma 1 also possible. Rom Anuj, you can do it happily. Because we have written previously 12 comma 1, 1 comma 12. Na? Like that we can use it. With the step also we did here. with the step also we did. So this is, I did not use that. So I hope that you understand the meaning of which one? Meaning of which function we got it? Meaning of which function we got it? Quickly. Yes. Did you understand? Fine. This is a way how you can design it. This is a way how you can design it. Okay, na? Yes. Fine, my dear students. Let us move to the further discussion now. Let us move to the further discussion now. Suppose if you try to apply, you see 2 comma 2 comma 2 comma 4. See that cannot reshape the size 8 into these possibilities. Cannot reshape the size like this. It is nothing but three-dimensional picture. I am trying to keep it three-dimensional picture. 8 is a size. 2 into 4. You cannot print like this. See carefully. You cannot print like this. So you cannot print like this. Are you able to get my points? Are you able to get my points? If you want, you can just redesign it. A is equal to, I'm just saying this. What is this? 1 comma, what is that now? 17. 1 comma 17, for example. Yes, sir. Print of A, or just A you print it. A you print it. See that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now B is equal to A dot reshape of 2 comma 2 comma what? 2 comma 2 comma what? 4. You see that B you printed. See, my dear students, three-dimensional also I am printing. Multiply 2 matrices. Each one is containing 2 into 4. First matrix 8 elements, second matrix 8 elements. So total is 16. Did you understand this formula? How to prepare it? Did you understand this formula? How to prepare it, my dear students? Yes, sir. So totally how many elements are there? 16 elements are there. Depends on 16. You can design also, not a problem at all. Not a problem at all. Right? Is it okay? Good. So I am trying to write like this. 2 comma 2 comma 2. 2 comma 2. 2 comma 2. See that. What is the 2 comma 2 comma 2? 2 comma 2 comma 2. Print B. Beautiful. Beautiful. What a beautiful. How many matrices are there? 4 dimensions. First dimension, second dimension, third dimension, 4 dimensions. 4 dimensions. 4 dimensions containing what? 4 dimensions. 4 matrices are there. Each matrix contains how many? Each one is containing 2 matrices. This is called 1. See, this is first of all 1 ma. This one is 1. Next, this one you take it. This one is up to here. This is 1. This is called what? This is called 1. This is called 1 more. And this is called this total thing. Beautiful logic this is. Are you okay? Are you understanding how to reshape it? Printer. B dot endim. See, what is that endim? 4 dimensions. 4 dimensions. Beautiful. D type. D type is a simple shape. I will write it. Shape. What is the shape? What is the shape? In 4 dimensions. In 4 dimensions. What is that? Two dimensions are there. Each one is containing 2 matrices, which contains 2 rows and 2 columns. Beautiful. What a beautiful example it is. So I will bring this example. Beautiful example this is. Additional example. So depends on the number of possibilities we have to understand. we have to understand. Is it okay, guys? See, clear. Shape of it, dimension of it, we got it. Yes. This is called one matrix. This is called one matrix. This is called another matrix. If you want a gap, you can have it, but try to understand. Is it okay, students? Students, are you okay? Yes. Fine. Shall I go to the next function? Did you understand? Which is designed with 1D. First it is created with 1D. We created with 1D. See, a range function, begin, end, stop, etc. Depends on the number of elements. I can reshape it. We cannot reshape without any such kind of things. We cannot reshape any such kind of things. I hope you are following me. What I am discussing it. Okay, right. So coming to the point back, next function, I just want to go for it. Shall I go to the next function, guys? Shall I go to the next function? Yes. What is the next function I am going to introduce? What is the next function? Can you tell me? I will go for next function here. Next function I am going to introduce. What is the next function? I'm going to introduce which function? Zeros function. Which function? Zeros function I'm going to introduce. So simple for you to understand. What is that zeros function? Which is going to build which matrix, my dear students? Which matrix it is going to build? It is going to build zero matrix, which is very simple. Let me take the third function. Zeros function. I am taking that. Yeah. Here I will take it zeros function. Yes. It is nothing but a null matrix we can call mathematically, but in Python we call it as what? Zeros matrix only. Null matrix exactly. But in our Python we call it as zero matrix. Okay. Contains only zeros. Very, very simple. Look at that. From here onwards, you will follow very easily. This function is used for building. What? Used for building zero matrix, which contains all elements as zero. As what? Zeros. Which contains all elements as zeros. Right? And we will specify what exactly the syntax is. Look at, my dear students. ndarray object is equal to numpy dot zeros. We need to specify the shape. And we need to specify the D type. D type is nothing but int type or float type or like that you can specify. Come on, how do you use it? Shape we need to use. Which type of shape of the things you want, we can easily go for it. Let's move to the further. Let's start the discussion. A is equal to np dot. Now I will take it. First example, import. Actually need not to write, because as a notes part I am just taking numpy as np. A is equal to np dot zeros of. I am writing just like what? Just observe it. Here shape can be either 1D or 2D. You can specify. For example, I am specifying something like 6. I am specifying 6 I am specifying. So only 1D I am specifying. 6 means it is 6 elements you want. Print A. Print of A. Just observe it. Print of A. Just comma. Type of A. What is printed? 0.0.0. What is the type? ndarray. You can reshape it. How do you reshape it? B is equal to A dot reshape. What is that reshape? 3, 2 or 2, 3, whatever you like it. Am I clear? That is already we are familiar with it. B, it is printed like this. So 0.0.0.0. I want to build with int type values. How do you do it? Simple. Go for that. Now I am writing. What is that? 4, 3, 4, 3, 4, 3. I am specifying 4, 3. D type 4, 3, comma D type is equal to int. I am writing int. See, int. Yeah. 1 minute, 1 minute. So I need to write like this. See, it is shape na. Shape means what? 4, 3. D type is equal to int. See, carefully observe it. All of you. 4, 3. What is this 4, 3? Rows, columns. D type is equal to int. See that? A. Print A. See that, ma? All of you. Zeros. Full of zeros. 4, 3. 4 rows and 3 columns. I can reshape also. 3, 4 also. What is the type? 0.0.0 is not coming. So I will say what? B is equal to A dot reshape. What I can say? Come on, ma. 6, 2. Can I use a 6, 2? Can I use 6, 2? Yes. Print B. You see that B, 6 rows and then 2 columns. Whatever the shape you want, you can do it. See, I will use it. This is a shape is equal to tuple format I am specifying. D type is equal to, it is a keyword argument type. You can use it. You can happily use like this also. How do you use it, ma? You see, shape is equal to, you can also pass like this. I hope you can write 3, 3. D type is equal to, happily you can write it. What is this concept called? Keyword arguments. Keyword arguments, we can use it. See, Tausif, I am saying that these are all related to data science level. Null matrix, for example, A plus, in our matrix level, A plus I, identity, A plus a null matrix. In our logics, if I want to keep track of number of elements, list elements, we write S is equal to 0. Did you remember? S is equal to 0. S plus I, like that we are doing the right or not? Like that, I want to do multiple matrix additions. That time what I will do? S plus S means what? Null matrix plus first matrix. Next, first matrix sum will come. Next matrix sum, I will go on doing it. Am I clear? So like matrix summation, if you want to do it, I may use this null matrices. So we will learn the operations here. Those who are looking further for data science, you will come across these operations. Plus additionally, you will get some type of algorithms in data science. Data science related NumPy kind of functions will come to you once again for you. Okay, right. Now print A. So see, print A. Shape is equal to, I used here. Shape is equal to, I used here. A, I just printed here. Print of A dot shape. Three, 3. A dot dim. Like this. Is it understandable? Can I convert into 3-dimensional this one? Can I convert into 3-dimensional? Can I convert into 3-dimensional? Think carefully. 9 elements are there. Can I convert into 1, 3, 3 is nothing but what, ma? One matrix only. 3, 3. Ram Anuj. Milan 2, 2, no, ma. 2, 2, 2 is becoming how many elements, Milan? 2, 2 comma 2 comma 2 is how many? 8 elements only. Is it possible to have 8 elements? No. Milan, do you see? According to your requirement, I can do 4 comma 2. 4 comma 2 I will take it. 4 comma 2. A. Yes, I got it. Now you say B is equal to, sir, A dot reshape of 2 comma 2 comma 2. 2 comma 2 comma 2. B is equal to, now I got it. Milan, are you understanding, Milan? Yes. So I hope you are understanding this mechanism. D type is equal to, I got it. Even I can reshape it to any of my requirement. I hope you are understanding my discussion. And before that, there is something else also. Before that. Yeah, it is going to be available like this. So here also I will take this part. See, my dear students, NumPy, only shape is mentioned directly. Shape of it. Now I got it. Now it is, of course, it is going to be called some error. I got it. Now later I written 4 comma 3 in the tuple format. D type printed. I reshaped it. I got it. And later I specified in another way. I got it. Next I mentioned 4 comma 2. Yes, it is 2-dimensional printed. I designed for 3-dimensional also. I got this stage. Is it understandable? Zero function is also creating what? Zero function is also creating which object? ndarray object. ndarray object. A range function also creating what? A range function also creating what? A range function also creating what? ndarray object. ndarray object. Here you see ndarray object. Here I will write it now. Once I will write it. Of course. Okay, it is written. I will write it. Print type of A. Type of what? A. It is going to print like this. ndarray only. Under that A I am printing, I got the data. Are you understanding? See, these are the number of approaches to create an object of what? ndarray. Shall I go to the next function once? So simple, students. Tell me, what is the use of once function? Tell me, everybody. Don't take much time of it. It will build what matrix? Once matrix. Once matrix. Which function? It will create a matrix with what elements? With what values? One only it will create like that. Zero function, I will take it. It will generate clearly once function only. Look at, my dear students, easy for you. I will take this example. I will paste it here. This function is used for building a matrix which contains all elements as what? One. As one in the bracket 1. What is the example here? 1. Shape of it once that is. Once. Shape of it is D type also I am specifying. D type. Let us go to the example. Not at all difficult. For you, you can do more easily. Nothing difficult about it. Yes, import what? NumPy. Yes, np. Yes, A is equal to np dot once I am taking 6 I am taking 6. D type is equal to what? Int I am taking. Print of what? A comma. I am writing A comma. Type of A. All elements are one only. 6. I can reshape it. What is that? A dot reshape of what? 6 elements can be rebuilt as a 3 comma 2. 3 comma 2. Sorry. 3 comma 2. Reshape of 3 comma 2. Print B. B is like this. Once. C is equal to 2 comma 3. 2 comma 3. 2 comma 3. I am saying that C, it is built like this. It is built like that. Now see that. Come out of that. Now I am going to use examples here. Now I am taking like this. So coming to the point of it, B is equal to A dot reshape of 3 comma 2. After that, I got the elements. Reshape of 2 comma 3, I got the elements. Dear students, are you clear? Am I clear about that? This is in the case of what? One dimensional I build. You want to build a 2-dimensional? You can. A is equal to np dot once. Directly you can shape of 4 comma 3. D type is equal to what? Int I can say. Int. A you print it. A. You print A. That is printed. I can reshape it, not a problem. A dot reshape of what? 3 comma 4. Print B. C is equal to A dot reshape of what? Build. One more, please. 3-dimensional you build it. 2 comma. 2 comma. Yes, please. 3 comma 2, can I write? Yes, Taushif. 2 comma 3 also you can write it. No problem. 2 matrices. Each one contains 3 rows, 2 columns. You can happily write. See, you write it. See that? 2 matrices. Each one contains 2 rows, 3 rows and 2 columns. D is equal to, yes, students, you see D is equal to, yeah, I'm writing 2 comma 3 also you can write it. 2 comma 3 also you can write it. 2 comma 3 also. What is that now? D you write it. See that? D you can write it. So whatever the 12 is there, that 12 multiples you need to take it. Are you okay? Write it as simple students, very simple students, not at all difficult. Yes, these are all creating what? Objects of what? ndarray only. So different objects are created. Now I want to go for once is created. Difficult or easy now? Is it difficult or easy? Easy, sir. Nothing is difficult. Once we have the strong Python programming, it is dead easy. Dead easy for you. Okay. Next I will go for which function? Which function, students? Next, which function, ma? Full. I am taking full function. Yes, dear students, are you following me? And 2 students yesterday got a job in big companies. Again, big companies of our Python student and Java. Shall I show you their message? Yes, sir. I will show you that. Let us, because yesterday they sent, today I have seen that messages. I will show you that. Right? Yeah. Look at that. I will show you that, all of you. Because if I show you these messages, it is just like a boosting for you. That means you also will get up. Since they practiced well, I will also practice very well. I will get the job also. Like that, we need to go for it. What's a web? Now, let's take into consideration, dear students. Directly, I will go to this point. Yes. Yes, ma, Lavanya, 2022 means you are still, you are under, you are still, ma, still you are a very fresher, ma. Okay, look at that, my dear students. Namaste, sir. I am Vedant Joshi. He is my former, previous Java and Python student. I am currently training as a backend developer in an IT company. He is a Python student. He got a job in Python. So he's praising me, our class in things and everything. Things and everything. So see, this is the one he is saying to me. This is the one he is saying to me. Finally, I told in the today only at 11 o'clock, congratulations, Vedant, I said. And later he's saying that all credit to my success goes to you, sir. Later he said pranam or something he said. And one more student is there. One more student is there. He is my another person, another student of mine. So he's, I think so. Yeah, he's another student. Sir, this is a Saipun Ray. He is my student who's a different name. Saipun Ray. He's from Odisha. So I proud you are my teacher and you are my best teacher of life, sir. We should teachers. Okay, this is okay. Come down to this next. Hi, sir. This is Saipur. This is a previous notes, previous student. Yeah, yesterday. This is yesterday. You see that it is yesterday. Yesterday's message. So this one, he said, sir, you remembered me. Sir, I got 3 offer letters giving a deep knowledge to me. Sir, giving the deep knowledge to me. So Capgemini and HCL and then Centrox-wise solutions. So this is his things. So I said today, 11 o'clock, congratulations, Saipundre. God bless you. This is what he said like this. Did you understand, students? This is what their things. So by seeing that, what you are getting, what you are understanding, so you will also get easily the job. Only thing is you prepare well. Because they are also like you, they are also practicing and definitely you will get the job. Without, once you prepare well, from our notes, nothing will go out of it. Everything will be from our notes only. Shall I move forward? Yes, let's go to the once function. Let us go to the full function I am going to introduce. What is the function name? Full function I am going to introduce. Full function. What is the use of full function, my dear students? What is the use of full function, my dear students? Tell me. Quickly, I want to know the answer. Yes, it is used to generate. It is used to create a matrix with our own element. With our own element. That element will be the full element in the matrix. Zeros, full zeros. Ones, full ones. There is no 2s, there is no 3s, there is no 4s, 5s, 6s, 7s. So full is coming. Full is coming means what? Full of ones, full of zeros. Now I am going to create what? A matrix which is initialized with the same element with full of elements. Are you understanding full function? This function is used for generating a matrix and initialized with the specified value by specifying the shape. By specifying the shape. Let us understand the syntax. Syntax, you get it first. Syntax is equal to ndarray object. ndarray object. ndarray object is equal to np dot, that is numpy dot full numpy dot full, come on, shape comma fill value. It's a very important syntax you need to remember. Fill value d type, this is a syntax. Shape comma fill value comma d type. Shape comma fill value comma d type. Which shape you want, you see. Fill value, which value you want, you specify. And the d type you specify. Come on to the example, you come first. A is equal to First of all, let me write like this: import numpy as np. Actually, I need not write, just I am writing because there is a special example I want to write it. Come on here, a is equal to np dot. What is that? One full 3 comma. What is the 3? What is the 3, ma? I will say 9. I am saying like this. What is the meaning of it? You please say. A you print it. Print of a comma type of a. Type of a. What is that now? 3 means 3 elements. One dimensional array. 3 elements with how many? What elements they are? What elements they are? Yes, ma, Vishal, I already told you in the class how to add the elements to the list dynamically. In the beginning only. Did you remember append function we used? Vishal, did you remember how to access the elements dynamically to the list? We already told you in the Python programming itself. So simple. Read our notes. Everything you will find. Yeah. Three elements of what type? 9 I want. Yes. Good. Now, A you print it. See, A you print it like this. Now I want to print A is equal to np dot full. What I want? Now you say 3 comma 4. 3 comma 4. Which element I want to go for it? 6 I want. What is 3 comma 4? Shape. What is the 6? What is the 6? Value, number, fill value. Taushik, very good. 6 is called fill value. I want to fill 3 comma 4 entries with what value? Only 6. Print A, beautiful. See that? 3 rows, 4 columns. 3 rows, 4 columns. 12. What a beautiful. B is equal to A dot reshape of 12 now. I can say, what is that? 6 comma 2. 6 comma 2. 6 comma 2. Say B. I got it. C is equal to A dot reshape of 2 comma 3 comma 3 comma 2. 3 comma 2. What is this matrix? Two matrices. Each one will contain what? 3 rows and then 2 columns. 3D I want. C you print it, beautiful. 2 matrices, matrix 1, matrix 2. Each matrix contains 3 rows and then this one. D is equal to, I can write D is equal to, what is this now? 2 comma 3. You see print D. 2 rows, 3 columns. 2 rows, 3 columns. How many matrices? 2. Easy or difficult? Easy or different? Easy, sir. Are you following me? Yes. Simple, sir. Nothing is difficult, sir. So, see, from here, you must understand. So, at any point of time, we can easily answer such questions. I'll just take it, come down to the point of it. I'm going to take it here. This function is used for building a matrix, building an object of ND array with a specified value with a specified shape, and D type is optional. I may write it, I may not write it. So this is 3 and print of this, and I got it. And A, I got these elements. Yes, sir. Fill value A, I got these elements. Here I got these elements. A, B, I got it. Yes, done. Now C, I got it. I got it. This is C comma. I got these elements. Next is called what? 2 comma 2 comma 2. I got this output. I got this output. Now I got this result. I hope that you got the result. You got the result. Full function is defined. Is it easy or difficult? Function is done. Easy or difficult, all of you? Easy, sir. Next, the sixth function I'm going to talk about it. Sixth function I'm going to talk about it. What is the sixth function? I function. Don't leave the session. Listen. Don't attend only up to 7:30 because still 20 more minutes. I will complete the functions. Because according to my schedule, I have to complete the ndarray object, how to create it. I function. These are dead easy for you. Nothing is difficult. How to create an I function, sir? Which is very, very simple, sir. How to create an I function, sir? Let me talk about I function is used for basically, actually, sixth and seventh functions. Identity function. Identity is there is one function is there. This identity function is used to build a identity matrix, unit matrix. Have you heard about unit matrix? Have you heard about unit matrix? Yes, sir. Unit matrix. It is called principal diagonal elements are what? 1. Other elements are 0. Other elements are 0. Am I correct? Am I correct? Principal diagonal elements are 1. Other elements are 0. So, always identity matrix is a square matrix. Am I correct? Identity matrix is a square matrix. That means rows and columns must be same. Rows and columns must be same. Okay, na? Rows and columns must be same. That is always build the identity matrix without any doubt. Okay, now, but when you come to I function, which is a flexible format of identity function. Flexible format of identity function. This I want to design. I want to give you some little bit more clear here. Little bit more clear I want to give you. Little bit more clear I want to give you the clarity. So I function is a flexible form of this identity matrix. For example, let us take one small example. All of you should monitor this part. This is my matrix. This is my matrix. Assume this is my matrix. Yeah, take very, very special care. So here I am taking something like this. This is my matrix. This is my matrix. What are the elements present in that? See, I take 1, 0, 0, 0, 0, and 0. 0, 0, 0, 0. What is this now? 6. 6 by, I can take 0, 0, 1. I will take a little spaciously. Please understand, don't get tension. And first of all, because I want to explain something more and more, you should enjoy that. Okay, if you want, you can go for like this, little spaciously. If you want, you can go for it. 0, and next 0, next, what is that? 1, next what? 0, next 0, next 0. Just next 0. Next I will take what? Next I will take what here? 0, and next 0, next 0, next 1, 1, 1, next 0, next 0, next 0. Next what I want? 0, 0, 0, and 0, and 1, and 0. Next, last and final I will take what? Last and final I will take what? 0, 0, 0, 0, 0. Last is called 1. This is called my 6 by 6 square matrix. This is called my 6 by 6 square matrix. Just for a minute, just for a minute. I'll take off this box which is not properly available. Which is not properly available. Let me flip off this. Yeah. So let me flip off this. Yes. So out. Now I'm taking something like this. Also carefully follow. Carefully follow. Yes. This is called one matrix. This is called one matrix. Fine. So, observe, follow me. This is called which matrix? 6 by 6 by 6. Am I clear? 6 by 6. What is this? 6 by 6. 6 by 6. 6 into 6. 6 into 6. Yeah. Here, what I am going to say is, this is called n, this is called n, this is called m. What is n? Understand everybody. What is n? Rows. What is m? Columns. Okay. And here, what is the indexes of this? What is the index? See, 1 minute you understand. This part is called a principal diagonal. Is it principal diagonal or not? This principal diagonal, this is called principal diagonal elements, this is called. This is indicated as a zero diagonal. And this one is called what? This one is called -1 diagonal. Which is the -1 diagonal? This one. Below principal diagonal is called 0, -1 diagonal, this is called. -1 diagonal it is called. This is called what diagonal again? This is called which diagonal again? -2. -2. This is called a -3. This is called a -4. This is called a -5. Above the principal diagonal, this is called 1. This is called 2, 3, 4, 5. This principal diagonal is recognized as a K. Is recognized as a K. What is the default value of K here? What is the default value of K here? Yes, please. Default value of K is what? 0. Yes, please. This is called what? K is equal to 0. K is equal to what is this now? -1. Next is called -2. Next is called -3. Next is called -4. Next is called -5. What is this is called? What is this is called? 1. This is called 2. This is called 3. This is called 4. This is called 5. 5. Are you okay? Are you okay, guys? Suppose this is called, how many parameters are there? N is there, M is there, K is there. Now the syntax of the function is numpy dot ey I function n comma m comma n comma, because actually it is a complex syntax. That's why I prefer to tell you none comma k. I am specifying k is equal to 0. n comma k is equal to 0. What is the purpose of this I function? I function is used for building n into m matrix by considering the k is equal to 0 as the principal diagonal. If I write it numpy dot, see numpy dot I function, what is n? 6 if I write it, 6. If I write 6, it is automatically taken n value as m value. See, m value is by default made as none. Internally, m value made as none. When I say 6, automatically that 6 will be taken as a m also, because unit matrix is a square matrix. Are you understanding? If I write 6, do you know what is happening? It will prepare 6 into 6. Here we are mentioning n is equal to 6 and automatically taken as what? Automatically taken as m is equal to n. M is equal to n. So it is called what? 6 comma 6 only. And principal diagonal as 0, that is called k. That is called k, by default k. Observe it. Go there. Yes, please. Import numpy as np. If you observe it, then you can understand. A is equal to np dot I of 6. I'm saying 6. A you print it. D type is also there, 1.1.1. And you please roll back that, because I will create comma D type is equal to D type is equal to int. I am saying int. I am saying int. So A, you print it. You see carefully. 1 1 1 1 1 1 1. 6 by 6 this is 6 by 6 this is n value is taken as what? M value is itself is n. K is equal to what? 0. Did you understand me? Did you understand me this part? Yes, sir. Please go. Please go. What is this value? What is the default value of this? K. K is 0. Now I am writing. See, carefully observe it. Now I am writing. K is equal to -1. I am writing -1. 6 by 6 only. 6 by 6 only. But K is equal to -1. K is equal to -1 means what? This will become will become what? 1 1 1 1 1 1. Did you understand? This will become 1 1 1 1 1. Whichever element you want, you can make it. K is equal to -1, comma. See, my dear students, A is equal to, see, my dear students, 1 1 1 1 1. Observe it. 1 1 1 1 1 1. Are you understanding me? Is it clear? Is it clear? Yes. Come on, my dear students. Next, K is equal to -2. K is equal to -2. A is equal to, see that 1 1 1 1 1 1 again. 1 1 1 1 1 again. My dear students, see that K is equal to what? 1 I am writing. 1 means what? This one. This is a principal diagonal. Na? This one will become what? 1. Above principal diagonal, print A. You see that 1 1 1 1 1. K is equal to 1, 2, 3, 4 I will write it. K is equal to 4 I will write it. K is equal to 4. I am writing 4. What is A? See that 4. This is called 4. Are you understanding? Yes. Next I am going. Go. Now I am writing. Shape is equal to, now n comma, now 3 comma 4 I am going. Three comma 4. What is n value? N value, please. M value, please. What matrix will be formed? What? No, Ram, listen, don't think by yourself. Listen. What matrix? 3 by 4. How many elements are there totally? How many elements are there? 12 elements are there. From the 12 elements, it is preparing internally square matrix. It is preparing internally square matrix. What is the square matrix possible elements? 3 by 3 only it can prepare. Can it prepare 4 by 4 or 3 by 3? 4 by 4 is loss of data, and then 3 by 3 is called what? Sufficient. So it can prepare 3 by 3 now, 4 by 4. It can prepare 3 by 3 now, 4 by 4. Yes, it can prepare. Everybody, 3 by 3 only it can prepare. In 3 by 3 unit matrix will be prepared. The rest of them, how many elements are prepared? Rest of them, how many elements are there? How many elements left out? How many elements left out? 3 elements. The 3 elements are zeros. 3 elements are zeros. Did you understand? Did you understand? Yeah. What is the example? It is going to be taken as 1 0 0. First of all, 3 rows, 4 columns. This is the data. See, 0 1 0. What is this? 0 0 1. Other elements are filled with 0. Actually, this is called what? 3 comma 4, which is building inside of it. This is called a 3 by 3 unit matrix is prepared. Rest of the 3 elements are called 0. Did you understand? Print. What happens, ma? Okay. 1 minute, ma. 1 minute, 1 minute. I say n is equal to 3, comma, m is equal to 4, comma, d type is equal to int. What is it? Yeah, 1 minute, 1 minute, 1 minute. I will just take it. Don't worry. Just for a minute, ma. Yeah, I will just take it. I should not write inside of it, ma. Directly, I should write separately only. Because these three different parameters, na? 3, 4. Yeah. See, ma, no tension. Look at, I got it. 3, 4. 3, 4. 3. See, 3. I got it. Yeah. Here also what? Got it. You print one more time. 4, 3, you write. 4, 3. 4, 3. 4, 3. How many rows? How many rows? 4. 4 rows. How many columns? 3 columns. What is the matrix prepared? Can you prepare it? 0. Sorry. What is that? 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. This is called 0. How many rows? 1 minute. Something went wrong. See, 1 minute. It is called what? 4. 4 rows means what? 4 rows. 0, 1. So it is called 1, 0, 0, 0, 1, 0, 0, 0, 1. And these elements are what? Zeros will be filled. This is correct. In this 4 by 3, 3 into 3 unit matrix is prepared. This is called 3 into 3 unit matrix. Rest of them are taken as what? Filled with zeros. Are you getting my point? This point is clear. Print A. See the printing A. This only contains unit matrix. This is 0. Here these are containing zeros. Okay. Now you write. I hope K is equal to what you write it. In that unit matrix, K is equal to -1 you write it. See, K, comma unit, right? Comma. Yeah. See, print A. See that this is going to contain what? 1, 1, 1, 1. Somewhere or the other, it is supposed to prepare a unit matrix. See, this is called looking like a unit matrix. Yeah, students, are you following me? This is looking like a unit matrix. Beautiful. Okay, students. Yes. I will write K is equal to 1. See that A. What is that now? This is called unit matrix. This one, this part only. Unit matrix. This part. Okay, now. So, I hope that you are understanding N, M, K, D type. Let's go. I function, I am giving the clarity here. What is the I function? Carefully follow. This function is used for generating an identity matrix. Identity matrix or returns 2D array with ones. I'm writing with ones on the principal diagonal. And zeros elsewhere. Zeros in remaining places. Or what is the syntax? Just now I wrote the syntax now. Yes, what is the syntax now? This is the official sentence used for generating the identity matrix or returns or returns a two-dimensional array with ones in the ones on the principal diagonal and zeros elsewhere. Sir, what is the syntax, sir? ndarray object is equal to numpy dot what is this? I of n comma m comma what is this? N comma m comma m is by default what? None. M is equal to what? By default what? None. I am writing comma k is equal to 0. N comma m is equal to none, k is equal to 0. Sir, what is this here? Now see here n represents what? Rows. N represents rows. Next I am writing m represents what? Columns. N represents columns. Right. Now, if we don't specify in the bracket, if we write it, or separately I will write it. K represents, I am writing K represents principal diagonal. In the bracket I will write it. If k is equal to 0, then it is what is that? Principal diagonal. This is by default, I am saying. By default. Yeah, one more I will write it. If k is equal to -1, then it is below principal diagonal. Below principal diagonal elements. Below principal diagonal. You can take like this. Next, if k is equal to 1, I will say -1, -2, -3, so on. Below principal diagonals. K is equal to what? 1, 2, 3. Then it is. I can write it. Then it is. Yeah. Then it is what? Then it is above the principal diagonal. Above principal diagonal, I will write it. I hope you are following what I am talking. K represents principal diagonal. K is equal to 0, what is happening? K is equal to -1, -2, what is happening? K is equal to 1, 2, 3, what is happening? I just mentioned it. Is it understandable? And then examples are clear for you. Dear students, am I clear about that? Am I clear about this, ma? Or getting confusion? Any confusion, ma? No. Okay, very good. Simple, you can understand. Because when we are coming to this stage, we are well versed with the programming. Only one topic is there. After these things are over, whoops features are going to start, which is little complex. Of course, you can understand. I hope you can understand much better. Nothing to worry. So I will take, my dear students, this type of things, ma. I will take. From here, let me take it. Yeah, from here, I will take up to this part. Later, I will take other examples also. Here I took it. You see, 6 only. 6 means n only. M value will be taken automatically, square matrix only. See, principal diagonal elements. K is equal to -2. This is the principal diagonal elements, and I took it. Another example I will continue. This part I will take care. Let me take this part also. I will take it. This one. Yes, sir. I will take this one. Next, another part I will take it. Here I am getting. This one I will take it. Yeah. Here I am taking. See, here NP is equal to 4, 3. K is equal to -1. Int type is equal to. I got the data. Is it understandable, my dear students? I hope this is very simple for you. Last function I will take it. What is my last function? Identity function. Identity function, I function is actually so flexible. It is a flexible format of identity function. Last function I am going to give you the clarity. What the identity function is used for? It is used for generating the identity function only, without any type of other kind of things. Without kind of any other kind of things. Come on, directly. Example, please. Look at, I say import numpy as np a is equal to np dot identity of 3. That's it. Comma d type is equal to int. D type is equal to int. I am saying np dot identity 3. 3 means what? 3 by 3 matrix. No principal diagonal. You cannot alter the principal diagonal. 3 by 3 elements. Print of what? A comma type of A. Type of A. 3 by 3. That's it. You cannot alter principal diagonal here. If you write it, you say it is called 5. 5 by 5. You see A. 5 by 5. That's it. You cannot alter here. You cannot alter. Only principal diagonal. It is a fixed format of this. Last and final. You say 2. You say 2. It is going to print 2 by 2 identity matrix. 2 by 2 identity matrix. So coming to the point of it, identity function syntax I will give you. What is the syntax? ndarray object. ndarray object is equal to numpy dot identity of n comma d type. Okay, this function is used for, this function is used for building. Directly I am writing square building, of course, building identity matrix, which is nothing but square matrix always. Square, of course, identity matrix is nothing but square matrix always. I need not write, but I am writing it. Here, if you want, here n represents both rows and columns. And calls. So if I say n, it is equal to n into n. Nothing but what happens? Nothing but, yes, nothing but I am writing that is n into n. Are you following? N into n. Square matrix always. I hope you are understanding. Example part you take it. Example part I am taking. Examples. See my dear students here, very simple here. I am taking that examples here like this. Say import. Yes, I am saying taking there, getting like this. Examples. So I hope that today's concept is clear. We created number of ways to create an object of ndarray. Is it clear? Did you understand how to create an object of ndarray? ndarray, how to create it? Yes. In tomorrow's session, I will tell you how to perform the operations. What are the operations we can perform on ndarray? Tomorrow class I will explain. Don't miss tomorrow class. We will go for ndarray object creation in tomorrow class. Thank you. Good day. All the best. Good night.